Welcome back, guys. This will be now a speed run regarding to the AES crypto function. So here we will do the solution. We will print out those parameters, the initialization vector, the secret key, and also the return value. And then we will use this information to encrypt and decrypt the text to see if everything is working properly. All right, let's do this. Okay, so back to the Ubuntu VM. Let's have a look. The application is within AES. Oh, one challenge to recap all. And now let's make a solution directory and let's move this application into solution. All right, and then let's have a look with the JDX GUI once again. All right, so we've got, let's see, COM app hacking AES, AES crypto. Yes, so we've got the method encrypt message, and we want to get this plaintext parameter, this key. So we have to insert a code, key get encoded, to also get out the key, and then initialization vector and ciphertext. All right, let's do this. So we could do this on our own, but I mean, it's way faster to do this in Android Studio and then compile this application. So we write our code in there, compile this application, and simply have a look into the Smali part. So tools, Android Studio bin, and then bash studio.sh. Okay, so here we have an old project. This is our Smali support the hard way. This was it was an amazing job we did over there, but now we can close this, so it's not longer required right now. Okay, if we close this, then we've got our main overview, and we create now a new project, empty activity, and let's call it AES solution helper. All right, we have to wait until the Gradle build has been finished. We can observe this over here, and I will see you in just a moment. All right, the Gradle build has been finished. So now let's create a new class. Right click, new Java class, AES. Okay, so we create a method, public void encrypt message. Okay. So we want to have, maybe let's get the first part over here, this part. All right, so let's hit Alt Enter. Okay, so we are importing those classes, and let's add this as some exception signature. Okay, so now our code contains now key.get encoded. Okay, and then let's see, we also want to have this base64 system out approach in here. So we have to assign this to a byte array. My array, let's assign this. Okay, and then we want to print it out, and we can do it in the following way: on system.out print line, and we call base64 encode to string, and then my array. Yes, oh, the flags are missing. There we go. Yes, so this should work. Yes, this is perfectly fine right now. So we take this line also to print out those parameters over here, and also to get the initialization vector and also the return value. But this is our important line. And this is the line we are going to copy paste into the necessary parts and simply just adjust those parameters. Yes, so let's call this method in the main activity. So here we have to create a new AES instance. AES is equals new AES. We do not have a parameter, and now we can call AES.encrypt message. All right, Alt Enter to surround it with try and catch, and let's see if this works. So we run this application. Our smartphone is not being connected, and therefore the emulator starts. I do not want to wait until this emulator has been booted up. So let's put the smartphone in. Okay, here we have the smartphone, because this is a speed run and we do not want to waste 2 or 3 minutes on the emulator. All right, logcat, let's see. System.out. There we have it, perfect. We can also make some adjustments, maybe. That this one over here is, let's say, this is the key. Okay. Yes, perfect. This looks absolutely perfect right now. So let's build this application. Then we've got our initial code path, and we can modify this in any way we like. So we click Locate, APK tool D. We are decoding this application, and then we are having a look into this with Visual Studio Code. So Code, App Debug. Yes, I trust the author. Smally.com app hacking, AES Smally. There we go. Let's enable Java. Okay, and let's see. Our code got a little bit blown up right now. So this is our code right now, but I guess it's okay. Get encoded. We also need to include this one over here. So we start at line 22. Begin. Okay, and this one over here is the end. Alrighty. Yes. So let's take this part and let's insert it into the original application at those points over here. At the beginning, to print out this plain text. After this one, to generate this key, to print out the key, this one, the initialization vector, and ciphertext. So this is a lot of stuff, but we can handle this easily. So one challenge, whoops, not this one, apps, one challenge to recap all. And here we have solution, APK tool D, AES.apk. And then let's open this AES directory. Com, app hacking, AES crypto. There we go. We enable Java, and now let's see, encrypt message. So this is the first part, and we have to insert it over here. There we have it. Okay, in the last video we have examined this pretty intensively. So therefore we can skip this right now. We can remove those line numbers, okay? And now let's see if the transition is working. We're having P1 as our parameter. Okay, so P1 needs to be adjusted in our code. Let's see where. This one over here is our key. So V2 is holding our secret key. And then we've got this array print stream. Okay, we print out this key. So this is now our parameter. Oh, this means the first part is not necessary right now. Yes, this is not required right now. Okay, sorry for this, because we want to print out this parameter here. Okay, here we have parameter, then we've got a bunch of stuff, encode to string, base64, and let's see. We need to apply this over here. This is our encode to string, our byte array. So V2, yes, V2 needs to be replaced with P0. Okay, and that's all we need to do right now. We do not have to take care about anything else because we are at the beginning of this function. Everything else will be overwritten, beside the fact that we are having 2 less registers. So we need to increase this. Let's go up to 10. Then we can be sure that this works perfectly. Okay, this should be fine right now. Good. So parameter has been successfully printed out. Normally I would go and try to build this application. Maybe let's see if it builds. If it builds, then we can move on. Otherwise we might have to fix something. Solution AES, okay. All right, it does build, so for me it's fine right now. Now let's see. Now we are inserting after this line 21, this key. We are calling this getEncoded method. And then we are also going to call this one. Okay, so let's get into our code. Where do we have it? Over here. Let's get back into the original code over here. And now let's see, line 21. Here we have it. Okay, and now let's see. Secret key will be moved into V1. And this is matching perfectly. We are setting up something else. We are setting up v1. Is v1 further being used? Secret key, okay. This is fine. Do we have something else? v0. v0, we are moving key generator into v0. Are we using v0 in our own code? No, we are not using v0. So therefore we are not touching v0 and we are good to go. And I guess that's it. So the only thing we want to have a look into is this byte array. This byte array should be now our secret key. Let's see, this byte array is parameter v5. No, that's the integer value, sorry, these are our flags. v2 is our byte array. Move result object into, yes, this works perfectly. So let's see, v2, this is our byte array. And this one will be used over here. Okay, this is our byte array over here. This is perfectly fine. Let's see where we are initializing v2 over here. So we call the method getEncoded. So v2 getEncoded will be assigned this byte array, the return type, into our v2, and we can see we are using encode to string on our v2 over here. Our byte array is v2, and this one is also the return value from getEncoded. Everything seems to be fine right now. Okay, let's clear this up. This should also work. So nice, we already got this one also, this key. Now let's have a look into this initialization vector. Maybe a quick look if it builds. One application back. Oh, that's the wrong project. Let's see. There we have it. Let's go into the solution directory. Here we have it, apk tool B AES. Let's make sure that we have saved this file. Okay. So, I mean, if you mess up registers, this might not be recognized right now, but we can see we are not having some really bad Smiley mistakes in here. Okay, once again, we take our own application code, this one, copy, and now let's have a look into the initialization vector. Here we have get initialization vector byte array. This will be moved into v4. Okay, we have to insert our code in between. Now we want to print out v4. So let's see. And v4, yes, it will be overwritten. So this is not working in this way right now. Let's see. Okay, let's take this part really quick to the graphic tablet and have a quick look into this one, because here we have to make a little bit more adjustments. Okay, so let's see. v4, this one over here, this is our byte array we want to print out. This one can be once again ignored. I shouldn't move this all the time into this code right now, so this gets ignored. And then we've got my array. So this one is the original value, v2. Maybe let's write this down. v2 is the original byte array value. Okay, then we are using string builder on v4. So we are overwriting v4 at this point right now. Okay. And then let's see, we also need to replace this one with initialization vector, iv. Then we've got string builder, and here we've got encode to string. Okay, and we're using this, of course, on v2, because v2, yeah, this is our original byte array. What we can do, I guess, so let's have a look into this one. So what we can do, let's see. Yes, here's the end of our local variables. So this means we could simply move this object, this get initialization vector object, into v2 afterwards. So then we do not have to adjust anything. Let's first delete this part. Also those line numbers. I hope I have deleted it before, but we will figure out if not. Okay, then we've got local v2. All right, this is the byte array. So this is now the code. Let's see. Our cipher object will not be used down further, right? Let's see. No, here's the end of our Cypher object, v2. Okay, so what we are going to do right now is the following. We go into our code. Where do we have this? Over here. So we are moving this object into v2. So we are overwriting the Cypher instance, and v2 is holding our byte array. But the Cypher object, this instance over here, is not longer required anymore. We are not using it in our code right now. So therefore we can simply overwrite this register. And now we can see this is now holding our byte array. Let's enable this one. So v2 is holding our byte array. And v2 is being used over here as a byte array. And this is working perfectly fine right now. So yeah, this is the only adjustment we have to make. Everything else, let's see. I mean, v5 has not been known to this application at all. Therefore, this is no problem. And yeah, we just have to make sure that we're not overriding an important register. So let's get back to this one. Here we are returning out, and we are returning v3. So at this point, we are overriding v3, and this would be not good. Okay, yes. So here we've got v3, and we can see we are returning v3, this doFinal method. This doFinal method returned into v3 is this one over here, and this will override our Cypher text, which will be returned. This is not good. Therefore, what we are doing is, in our code, we are replacing v3 with v6. Doing this in this way, we are not overriding v3, and then we are done at this part. So the only thing we need to do is we need to print it out, the return value over here, and then we are done. So this part is now regarding to the initialization vector. Let's also write it in this way. Initialization vector, and then let's see. Yes, we only need to insert it once again. So let's copy this part. Let's insert it over here. Okay, here we're having now v6. It's okay because we have already printed out over here system out print line with v6 on v6, sorry, with v4, which is our string. But this system out is not longer required afterwards. Yes, okay. And then let's see. So over here, yes, we need to adjust this part over here, v5. We need to adjust v5, sorry, v2. We need to adjust v2 to be v3. Yes, this is our byte array, which comes from here. So this is our ciphertext, and we are not using the ciphertext in our code. So we can see on the highlight it's not being used. And the only place we are using it is over here. So v3 will not be overwritten, and we will use encode to string on this byte array. And then we are returning it. Okay, one last check. Did I miss something? No, okay, everything looks fine for me right now. So let's see. Okay, it does build. So AES, and then dist, we zip align this, we sign this, and then we have to uninstall, a screen copy, we have to uninstall the existing version. A little bit messy. Oh, this was the wrong one. If you take one of the above line, then you're not uninstalling it. You're just saying you do not want to have it as a suggestion. So let's take it here, uninstall it. Okay. And now let's install it. Yes, that's correct, because I need to install out APK. It's test only. Let's make this larger. Okay, and that's it. ADB logcat. Let's search for system out. So this was regarding to the last or our example to our own application. Now let's see if this works out in the way we have patched it. So let's see. We are calling AES in 3, 2, 1. Nice. Beside the fact that I didn't change the initialization vector at the end. Okay, so my bad on this. Let's clear the logcat output. ADB logcat-c. Okay, so we have to adjust this one. Where do we have it? Here. And this one is the return value. Okay. Yes. So here we are creating the string regarding to the return value. All right, this should work right now. So let's do it once again. I will speed up the build process and then, yeah, you will directly jump into this. All right, welcome back. So let's see. ADB logcat grep-i system.out. And now let's start this application. 3, 2, 1. There we go. Here we have everything. Also the text matches perfectly right now. All right, now let's use those parameters in our CyberChef function to see if we can decode and if we can encrypt and decrypt this text right now. Okay, so let's do this. So we are searching for CyberChef, and here we have this. And now let's see. First is let's take the return value. Let's try to decrypt this text. So this is our encrypted text. Okay, so this is our input over here. And we now say this is from base64 and we want an AES decryption, AES decrypt. So our input is raw because we are decoding this string, this base64 string. We can leave the output to raw and I do not want to have this auto bake right now. Okay, now let's see. What is the key? The key is this one over here. Key, the format is base64 and the initialization vector is this one over here. The format is also base64 and this is all. Okay, now we should get back, if we hit the bake button over here, our decrypted text, so our plain text. So let's see. Bake in 3, 2, 1. Perfect. Secret one-time message. All right. So this is freaking awesome right now. So we could also do it vice versa. So for example, we can use our text over here and we can encrypt it with the AES function. So let's pause this. This is decrypt. And let's take this text. And now let's see. AES encrypt we are having to use right now. Okay, the key is the same. Format base64. Initialization vector is the same. Format base64. Our input is now raw. It's neither raw nor hex. So yes, the easiest way would be to base64 encode it, because this is what we are doing over here. We are decoding it. So echo-n base64. So this is our text we want to encrypt. Okay. And our output is, let's say, raw. Okay, let's do this in 3, 2, 1. All right, now we've got the raw output over here. And to make sure that this fits perfectly with our screen, we are going to base64 encode it right now. So base64 to base64. Okay, so what's happened is the following right now. This is our text. And this text will be base64 decoded. base64-d. This is this block over here. Okay, then we've got an input raw format right now. Then we take this input and we perform our AES crypto function over here. Here we have this key as base64 format, sorry, initialization vector. Here we have the key. And then we get this out over here. And this is not readable for us right now. So what we have appended is this one. And this one is now taking this part, this output, and uses base64 to encode those bytes. So out of this, we will get back some base64 string with this equal sign, maybe regarding to the padding. Okay, so this is what's happening right now on the CyberChef. Let's do this. And therefore, all we need to do is we need to hit this bake button. 3, 2, 1. Okay, looks perfect. Let's see. Yes, this is exactly the same text. So now we can modify this text in any way we like. And for example, we could also create a new message. Where do we have it? Echo-n Udemy Smiley hacking is pretty awesome. Let's encode this to base64. Whoops. There is something missing. Let's see. Awesome. Okay, base64. So this is now the new text. And if we click bake, this would be the result on our screen. So we can now perfectly work with this encryption, decryption methods over here. Alrighty? Okay. This was right now super fast, but I do not want to bother you right now with things we have already seen. This one, for example, over here. I mean, regarding to string builder, appending things like this might be new, but it's simply just Smiley code. We have reverse engineered this whole class or this function quite a lot right now, and therefore I did go a little bit faster through this. The most important points are, at the beginning, check if these parameters matches with your parameter in the encode to string function. Increase those parameters, because this will be definitely required if we have a look into this one. V5 hasn't been used before, so we only had 5 registers. V4 is the last one, so this would cause problems. And then simply just take this whole code and paste it everywhere you wanna have it, and have a quick look into the transition. If this object v1 is, for example, secret key, if it stays secret key, if v0 is being used anywhere else afterwards, we can see, no, that's not the case, so we can reassign this and things like this. Alrighty? Okay. In case, if this was too fast and you want to have a longer explanation on this, absolutely no problem. Drop me a message, I will re-upload a more extensive version on this one, okay? So if you feel in rush right now, then please drop me a message, because this is something we do not want to have in our course. We want to take our time to analyze this, but I do not want to bother you to go through this the 3rd or 4th time, in case, until, of course, if it's required. Alrighty? Okay, perfect. So this is the end for our one challenge to recap all right now, and in the next one we will have the introduction to our black belt challenge. And this will be freaking awesome, because we will combine everything we have learned so far in this challenge. Alright, let's have a look.